Well, I'm Jess Freaner, and my talk today is called Effective Data Science, the Art of Delivering and Demonstrating Value. My slides will confirm that in just a moment. You're hoping to impact at the end. By thinking about their needs throughout, you're going to be able to really articulate and hone in on the right goal. And it just helps you get to a valuable result. Being hypothesis-driven through your project is really important for staying focused and moving forward. Because in data projects, as in life really, you have to make decisions on a limited amount of information. And it's really tempting to be impulsive or to just take too long in making a choice. So as long as you take a moment and think things through, you're gonna make better decisions this way. Rapid iterations is a great way to help you test out your different hypotheses, because you don't have to spend a lot of investment in any given one of them, but it helps you figure out if you're moving in the right direction or not. And you do that by incorporating feedback and then gradually investing more time and investment as you're honing in on the right direction. Being modular in the way that you structure your project is really important, because this helps you try different things more easily without having to start from scratch. It's also a great way to collaborate and have different people work on a project in parallel so that you get to results in a faster way. And I'm going to be talking about how these different components play into the life of a data project. In particular, I'm going to focus on idea generation, data exploration, coding, modeling, and UI prototyping. And it's all going to be anchored in a case study that we did for a real client. And it was Procter & Gamble, and it was a data-driven expertise exploration project. To start off, idea generation happens throughout a project, data project, but I'm going to be focusing on what happens before you even write a line of code or touch a piece of data. And it's because a lot of times when a client comes to you with a specific problem, you want to push back on their initial framing and find out what's really going on. One of the ways we do that is by conducting interviews with stakeholders and end users. This is a great way, especially when you do them one-on-one, to find out different hopes and fears and hear from lots of different perspectives on what a challenge it really is before you get started and decide on a direction. But we also like to bring these same stakeholders together, because it's important to get alignment on the direction that you're going to move forward in, and we like to do that in these workshops. Here we give them a series of prompts, and that way we get them to generate lots of different ideas about what we could potentially solving with our collaboration together. At this point, we really go for quantity and reserve judgment. There's no such thing as a bad idea at this stage, because a bad idea can lead to a good idea. You really just want to build on each other and go for like sci-fi possible of what you want to do. But then, of course, you use what you know about the world and you get them excited about a few different ideas. You figure out what gets them excited, you converge on those ones. But to figure out which is the one idea that you want to move forward on, we like to do this idea prioritization so that you get buy-in around one idea. Because when you have lots of different people together in a room, they're all going to have their own opinion about what's important to do first. By doing a prioritization like this, you can see how different ideas are connected and how different foundational building blocks are like the low-hanging fruit that can then lead to future projects. And obviously, ice cream is really easy and really important, so advocate for that always. We also spend time doing iterations and sketches of the end user experience. When you're developing an algorithm, it's important to consider how somebody's actually going to interact with it and how it might help them make decisions. By thinking of the different ways that it's going to impact people in the real world, you're going to have an ability to have the goal and plan your next steps. And really, you just want to work backwards from this UI and end goal. And that's a good way to make sure that you're staying on target, even if the exact path there changes and veers along the way. For Procter & Gamble, Kathy was the client, and she came to us asking to better see how experts were connected and distributed around the company. By asking lots of different questions, we were able to find out more backstory about the company structure. I mean, they're a multinational organization with over 100,000 employees, and they have these 10 product verticals. And the thing that's really important to P&G as a whole is not to allow the knowledge that they gain and develop over the years to be siloed in any one product vertical versus another. So they have these communities of practice that has people with the same role collaborate across different products. And Kathy, she was in charge of a research and development community of practice of about 200 people. And one of the things that was part of her job was to field these requests by researchers for experts in a specific field when they were tackling a problem. If you're trying to figure something out and you need an expert in ceramic, Kathy was your gal. She pointed you to the right person. And the way that she did this was that Kathy had this really incredible memory. If she met you, she knew your name, the last meal you had together, she knew your home life, she knew the thing you studied in college. She did not forget a face or a name, and it's kind of incredible. I've never met anyone else like her. But the reason Kathy was coming to us was she had a serious problem. She was so good at her job, she got a promotion, and 200 people became 2,000 people. And she could no longer remember or memorize all these different faces and all the different facts that were important to make those kind of collaborations. So how was she supposed to do this now that there were all these unknowns? Her process didn't scale. So we had a workshop. We explored different resources that were internal and external. We looked at that in partnership with analyses and visualizations of how we could leverage these different resources. This is with the stakeholder, but also the data scientists in the room, so that you're really generating and exploring what's going to be possible analytically and what would be useful. We did the whole prioritization game, and we uncovered a few different resources that were internal that could really be valuable, including structured ones like HR records where you could get demographic information, as well as different unstructured resources like surveys, as well as these internal research papers where you could see how different people were connected. And since these were researchers, a lot of times they would have to publish internally, as you might imagine. And in there, somewhere in there, would also be expertise. But how we were going to extract that wasn't immediately clear. It was something that I'll get to a little bit later when I talk to some of the modeling parts. We also generated a lot of hand-drawn sketches, like what I talked about, to explore how she might want to interact with the information we surface. Did she want to see a big hairball network where she could dig around and explore? Did she want to see timelines? Did she want to be able to link to the original resource paper? And by looking at all these components, we were able to find out what was important to her. And so we honed in on the idea of a search engine, one that showed demographics. After all, Kathy liked to know who she was working with. And we wanted to make sure it was really human readable, meaning that there wouldn't be any necessary training to understand how to use this tool. Making it simple was really important. All this helped us figure out how to then tackle the rest of our project, and this is what really anchored us moving forward. Now, when it comes to exploring data, there's a couple components I want to talk about. The thing you do when you first receive a new set of data is that you want to get a quick feel, right? You want to just figure out what's in the rows, what's in the columns, count some things, ask some really quick and dirty questions. Do this in your interactive environments. It's really great to write some stuff, throw it away. It's quick and simple. But you also, at some point, want to start to get to EDA that is a lot more tactical. And by this, I mean, you want to start imagining what questions are going to be worthwhile pursuing versus not. There's so many things you can ask of a given data set, and you don't want to end up in a position where you spend all this time coding up a question, and then all this time getting to a solution, looking at the result and saying, okay, now what? Back to the drawing board. That doesn't really work when you have to get to results fast. It's good to think through what questions are going to change the next questions that follow. It helps you figure out a path moving forward. At this point, I can't really show you the stuff that happened with P&G, so I'm just going to talk about a quick informal example. When I first moved to Chicago, I kind of wanted to do something fun. So I looked at Instagram data across Chicago, and I wanted to just learn something new about the city. My hopes were to find out where to go for brunch. But as soon as I started playing around in IPython notebook, or Jupyter rather, I learned how to work with the API, learned some different tools, and I plotted up a day's worth of Instagram posts on a map. And I saw something kind of interesting that changed the questions I was asking, because it looked like only part of the city was being covered. Was this a mistake? So I started thinking about it. If I put up all of Instagram on a map, and I also looked at population, was this just going to be another proxy for population? Or were there certain areas that are over and underrepresented? Was this going to matter? Maybe some people just like Instagram while others don't. But what if I looked at different demographics? Things like race or age. Were there other groups that were going to be over and underrepresented, and could I capture that in some kind of meaningful way? To pursue this, I went through a lot of quick iterations of the analysis of numbers, but also putting things up visually. From this, I was able to find out that certain groups, Black and Hispanic groups, were underrepresented significantly in Chicago, and this all led to a blog post that you're more than welcome to go check out and find out more about. It's on Datascope's blog, Partially Derivatives, and there was also another blog for Markets for Good that came out of this. But back to the rest of the topic. When you're talking about coding, the reason I'm talking about this separately from what I talked about before is that at some point, you want code that's going to stick around. So the stuff that you want to last and to work with long term should no longer be in an interactive Jupyter or RStudio. It needs to happen in scripts in a text editor. Each script needs to have one result, and you should name it so that you know what that is. You want to write as many short functions as possible and source and import these functions so that it's just more modular and useful. And if you ever copy paste, that means you should already be writing a function. And the reason that it's important to do many short functions, I mean, one, it's really easy to then debug and find out where something's wrong or going wrong, and you can replace that piece of logic and you won't miss it throughout. But what I think is even more important about the short functions is that it makes your code much more like human language, or it can be. If you write many short functions that make a lot of sense, you're writing for humans and not for computers. You're making your code readable. After all, the image on the right with left front wheel inflate is a lot more meaningful than some sort of run process 232 left. You understand one right away, the other one you have to take a minute and go, huh? So be thoughtful about your variable names. Leave comments to make sure that it's clear what the purpose of what your method is, not what it's actually explicitly doing. You also want to use those short functions in place of comments, and if you do them well, you can actually save yourself some typing. Now, the modeling component of a data project. This is what a lot of people think of when they think about data science. And it's important to do this in a modular way that can leverage all that modular code. And that's because you can break down the process of building a model into a few different components and parts. And all of those are things that you should feel comfortable swapping in and out and trying different things in all the different phases. And you want to be able to do all of that in parallel and all throughout your process. So if you have code that makes it easy to change out your inputs and your targets and your algorithms, you're going to be able to find out what result is going to work best. And if you have code that is modular, you're also going to be able to do this in parallel. So one person on your team is working on one approach, while another person on your team is working on a different approach, and you'll get to results faster. And I'm just going to focus right now on that target idea, because it's really tempting and easy to hone in on one metric as being what you are doing your data project on. It's kind of what happens in a Kaggle competition. Figure out how to do this one thing, that's your target, and then people are a lot more comfortable changing out the algorithms or the inputs, but not so much the target. But this is something you should feel comfortable changing all throughout up to the very end. And as long as you're thinking about that long-term goal that we talked about in the beginning, as long as you understand why the data project is started in the first place, you're going to be able to change this without losing value and getting to something that's more interesting. For expertise, we could look at the H-index and figuring out, how good a different researcher, not just the quantity, but also the quality of researchers within this organization, and we could calibrate exactly what that looked like and swap it out different ways. It's also important to at times filter down to a small trustable data set to build a good model faster. And what I mean by this is instead of trying to handle all of the world right away, if you focus in on just the US, figure out how to make that work, it's much easier to scale a model up than trying to account for all the different components from the onset. And when you're working with your inputs, at this point, I think it's really important to be hypothesis-driven because you're more likely to have the biggest impacts on your model with feature engineering and thoughtful feature selection than by tuning the parameters on a model. So this is where you're going to have the biggest impacts, and you just want to be thoughtful about how you're combining things and creating new inputs. So feel free to engineer and play around with what's going into your models. But like I said, with the algorithms, while the fine-tuning and the parameterization is something that you can do throughout, you also don't know a lot of times which model is going to be the one that pays off. Will it be a regression? Will it be an XGBoost? These are all things that you should feel free trying and swapping out, using that modular code and just testing out all the possibilities. You don't know which one's going to pay off, and if you try lots of them, you're going to get to something interesting faster than if you just try one to completion, start from scratch, try one to completion, start from scratch. And for evaluation metrics, some ones are really obvious to use, RMSE, finding where there's the least error across two models. It's good to compare them. But at some point, if you're thinking about the use case of your algorithms, it's important to realize what might go into that UI. Say I'm looking for referrers or some sort of target population. If I'm targeting a certain population, is it important for me to accurately predict where they're going to be or rank them in a certain way, or am I trying to capture the top 10%? Is the top 10% of the people that give you the most of the right kind of output and finding out who they are more important, or do I need to make it work for everybody? And by thinking about those things, you can change and create your custom evaluation metrics. It's actually a great way to also make it interpretable and understandable to the people that are going to be using it, and it's a great way to frame what you're working on. And now, just really quickly about UI prototyping. Not all data projects go into building out a prototype, interface. But like I mentioned, it's very useful when you're trying to figure out what goal you want to achieve in the long term and what you're really striving for in a project. But it's also really useful that if you are doing a prototype or an interface and you need to develop something that somebody's going to use, by thinking about those stakeholders and showing them along the way what you're working on and your different iterations of your project and your output, you're going to be able to find out what works, what doesn't, and you're going to find out in a faster way than if you try to get all the specs up front, build it out, and then show your results. And as you're iterating and building up, you can go through prototypes that include things like sketches. That counts as a prototype because you can get feedback and people will be more honest about what's crappy about a sketch than a really fancy built out UI. They're not going to be as honest. So if you can get that kind of feedback early, it's really important. But as you go through, you spend a little bit more time refining what you're presenting. And you're also going to be incorporating the lessons learned from the people that you're getting feedback from, but also from the data itself. Because for instance, for the PNG project, at some point we realized that it wasn't just expertise that was important, it was activity level. Because certain people who were experts in certain fields, at some point their activity level dropped really suddenly, and it was pretty weird. And by asking about it and presenting that, we found out that that usually indicated that somebody became a more managerial role. So they were no longer going to be able to participate in these research questions. So why surface them as being the top expert in ceramics if they were no longer going to be able to collaborate? So it was important to both indicate when somebody was an expert and if they were available and their activity level. So all of this helped us deliver a tool for Kathy that she used every day to do her job. And it really addressed the needs that she had as being in charge of this community of practice. And it's something we wouldn't have been able to get to if we just started off with the problem that she presented us in the beginning and ran with it. So this is all to say on your next data project, I hope you leverage human-centered design and remember the humans involved in your project. Stay hypothesis-driven to stay focused. Use rapid iteration to try out lots of different options and keep things in modular structure so that you can work in parallel and build for many people. Thank you.
Is this presentation available to us now?
It will be. Yes, the presentation will be available. Thanks. Yes.
I was wondering, how do you balance creating an automated version of what the client already has, so Kathy in this example,
right.
Versus actually improving the process?
Mm-hmm.
Because if you might produce an automated model that acts just like Kathy, but that might not be the best way to connect to experts. So I guess those seem to me competing, so how do you balance that?
I think that's a really good question. And that is something that when we're doing those interviews and those workshops, we kind of present the different options. We don't want to just say, how can we do what you're asking us to do? But also let's rethink if that's really what the problem is. That's a good way of pushing back. And when we were doing this, by scaling things up, we were doing things that Kathy couldn't have done, even if she knew all these things. So the solution wasn't just an automation. It was actually a new way of framing and tackling the problem. But that's a great question, and you should always look for opportunities to push back on what people are asking you to do, because a lot of times there's more that can be done and impacted with data.
Thank you.
Yes?
Oh, thanks. I was just curious if this concept of communities of practice is something that you're looking to extend and apply either to just one client or more broadly across multiple clients. And then also, you said you developed this for this individual. Are you looking at rolling this out? And what are the barriers to engagement and adoption by a broader set of users?
Well, this did have a very targeted user. Most of the ones that we work on they're not that targeted. They're more broad. So when we're doing that, that's why we like to do interviews and workshops with many stakeholders, and we try to present things and talk to them throughout the process. So in this case, this was for Kathy, but communities of practice is something, just to clarify, is a P&G concept. It's something that they already do to not silo information and knowledge internally. And I believe other organizations have similar or their own versions of that in order not to create silos, especially in these really big organizations like P&G. But the best thing to do to get to adoption is to use things like human-centered design practices, I believe, because that's when you're really listening and observing to what people's needs are and working to uncover what's underneath their statements before you start down a path.
How can you estimate the duration and the cost? How can you estimate the cost and the time for this type of project?
I mean, this was months of time, and the cost was, I can't say exact numbers, but there were a few data scientists working on the project, so, I mean, I probably wouldn't be buying it individually.
Because you need the client buy-in, and the
Right.
people who can buy in, you have to tell them how much time I need and how much is the budget and deliver the solution.
Right. Before we start off on any engagement, we already are going through all of the paperwork and the SOW, the statements of work, the proposals. We give estimates and an understanding of our cost. If we present that at the beginning early on, just giving a sense of what our usual pricing is for different things that we provide. If that's too high or too low, I mean, if that's too high, then we don't work with them. Like, at some point, you have to also appreciate the value of what you're producing and delivering, and you are running a business, so at some point, that needs to...
So your data science will do the on-site project, or just the data science can work in your own place?
Do you mean on, no. We,
How the data flow from the
right.
customer.
We don't stay on site with a client. What we usually do is we start off in the beginning doing some investigative stuff, diving deep. Sometimes we'll spend a few days learning in workshops. Sometimes we'll spend a couple weeks or something. But we work, we like to work together here in Chicago in our office, although, you know, people can work from home when they need to. So we don't stay at the
How
clients.
about the data? For example, the P&G, we have some sensitive data. We
Right.
cannot send you the customer's data file.
Right. Well, we have it always arranged that we have somebody that we communicate with internally that's on their technical teams or their data teams or their IT team, whatever it is, and we coordinate with them about what data we're allowed to have. We also sometimes do get sensitive data, but then we're under strict NDAs. We have protocols. We'll work through VPNs and sometimes only on certain laptops that they provide. Like if we're dealing with sensitive data, there's protocol that we can work with without having to be on site.
Can you give some example about what data you collected? Example of the data you collect?
Sure. For this project, one thing that we collected was we used Wikipedia actually to help us figure out what was going on in a lot of these papers because a lot of them were tagged, had certain topics. But what happened when people were searching for some kind of term or category that wasn't clearly labeled or wasn't human labeled already on these papers? So one thing we did was we scraped we downloaded Wikipedia and we used all those different articles that are curated to help match topics with clear labels on top of these research papers as well. So that was an example of something that we use externally on top of the data.
So it's text, right? It's text.
This was text-based, yes.
And who hosts the data? You host the data or you use the data from the client and their own data?
It depends on the project.
For this project,
For this project, in the end, it was the client.
the client collects their own data, right?
Right. In the end, when we work with clients, we hand over our analysis and our code and our work, and it becomes like the clients. We keep our intellectual property rights to certain tools that we develop. So the technique of working with Wikipedia, that's something that we retain, but they get the tool and the data.
So the client collects the data according to what you design, right?
Well, or according to what we request, or we collect the data. We do a lot of the collection as well, but if it's internal data, then we have to work with the in-house team to figure out what is necessary. Sometimes we get a lot more than what we end up focusing on. So we find out what's available, we ask to see a lot of it, see what we can use, and then focus in on that, and then that becomes the basis of the project. So it depends, but sometimes P&G, for instance, wasn't gonna give us emails. They had internal emails. That was one of our bad ideas in our workshop. We're like, how about we see when people talk to each other? And they're like, no. So there are certain gives and takes that you have to decide and negotiate.
Can you give what example of algorithm you used in this case? Algorithm. What kind of algorithm?
Ours.
Yes. Algorithm.
Algorithm.
Yes.
Yeah, well, I said that we did some topic modeling, but we did the topic modeling based on what was going on in Wikipedia, so we developed our own way of mapping that. So we created a custom way to do it.
I think we have time for just about one more question. I see a gentleman in the back here with his hand raised.
Hi, how's it going? As a data scientist, do you productionize the data pipeline and create a product, or do you have a team of data engineers to do that for you?
It depends on what the client project is. Sometimes we'll develop proof of concepts or reference material where if they have in-house capabilities, then we develop things and then hand it over. So sometimes it's a collaboration. Other times we can help maintain and continue to bring work into production for other clients. It just depends on the project. But we don't have separate engineers. We do the engineering ourselves. If we need to, sometimes we also do contract choose. We have certain people that we work with when we need additional resources. But otherwise, it's in-house generally. And that was the last question? And you guys can always come up to me later, so if you have more.